MCA Prep Day 2. Our first benchmark today is 8211. Understand that a function is a relationship between an independent variable and a dependent variable, in which the value of the independent variable determines the value of the dependent variable. Use functional notation such as f of x to represent such relationships. All right, so dependent and independent variables. So independent and dependent. The independent variable is x, or the input. Independent is input. So you're going to put something in for x, and then you're going to solve for y. So that makes y the dependent variable. So x is input, and y is output. So we're putting something in for x and seeing what we get out for y, or f of x. So f of x is the same as y. They're interchangeable. So let f of x equal 4x plus 5. What is f of 12? So notice where the x is, it's been replaced with the number 12. So what that means is we are going to replace the x with 12 in the parentheses and where you see the other x, like this. And because it was 4x, that means 4 times x. So 4 times 12 is 48, plus 5 is 53. So f of 12 equals 53. The next one, f of negative 3, we'll do the same thing. Replace the x with negative 3 in both places, like this, and then solve it using the order of operations. 4 times negative 3 is negative 12, plus 5 is negative 7. Our next benchmark, 8212, says use linear functions to represent relationships in which changing the input variable by some amount leads to a change in the output variable that is a constant times that amount. So let y equal 7x plus 3. The value of x changes by 1 from 2 to 3. By how much does the value of y change? So first, it says that we are going to replace the x with 2. Then we are going to replace the x with 3. So from 2 to 3. So I'm just using this relationship. Y equals 7 times x plus 3. 7 times 2 is 14. Plus 3 is 17. 7 times 3 is 21, plus 3 is 24. So what has happened to y is y increased by 7. So increasing x by 1 resulted in an increase of 7 for y. The reason that happened is because there's a 7 next to the x. You're multiplying whatever x is by 7. So increasing x by 1 doesn't increase y by 1. It increases it by 7 because it's multiplied by 7. The next one says the value of x changes by 6 from 2 to 8. So we already know that when x is 2, this resulted in 17. Now they want us to change it. Now they want us to change x to 8. So y equals 7 times 8 plus 3. So that would be 56 plus 3, which is 59. So now the change is not as small as the initial. We go from 59 back to 17, we see that it has increased y. So y increased by 42. Again though, now x was changing by 6, and because x is being multiplied by 7, 7 times 6 is 42. Where first x increased by 1, 7 times 1 was 7. So whatever you're increasing x by, that constant of 7 in front of the x makes y increase by 7 times that amount. Our next benchmark is 8213. Understand that a function is linear if it can be expressed in the form f of x equals mx plus b, or if its graph is a straight line. So linear means that we have this form, slope-intercept form, f of x equals mx plus b, or the graph is a line. The graph is a line. Now, part A says, what term best describes the graph of f of x equals mx? Now, I'd like you to notice that f of x equals mx plus b. This is slope-intercept form, where m is the slope of your line and b is your y-intercept. So if you compare what they're asking us about here, f of x equals just mx, there is not a plus b. There's not a plus b on this equation. So what that means is that this is going to be, what term best describes it, this is going to be linear, and it's going to be a line through the origin. A line through the origin, which makes it not only linear, but proportional. So linear and, oh, my board is off. Sorry about that. So this is going to be linear and proportional. So again, because it's a line, and the intercept is zero, because there's no y-intercept. That makes your line go through the origin. So it's not only linear, but it's linear and proportional. A possible graph would be any line that goes through the origin. The intercept is 0, the y-intercept is 0, and you can make the slope whatever you want, positive or negative. So there's an example of a possible graph. Our next benchmark, 8214. Understand that an arithmetic sequence is a linear function that can be expressed in the form f of x equals mx plus b, where x equals 0, 1, 2, 3, and so on. Okay, so an arithmetic sequence, so that means a pattern in which the same thing is being added or subtracted over and over in your sequence. The same thing is being added over and over in your sequence. So f of x equals mx plus b is our general form for an arithmetic sequence. And the important things to know are what you substitute for m and b in this equation. B is your starting point, or the first term in the sequence of numbers. So for this sequence, b is 3. Now m is the common difference, So that means how much is being added over and over or subtracted over and over. So how much is being added or subtracted from one term to the next in your sequence? So looking at all of these numbers, I can tell that my common difference is 4. It's 4. 4 4 is being added each time. So now I can write my equation over here. So m is positive 4, it's going up 4 every time, and b is 3, the first term in the sequence. So f of x equals 4x plus 3. Now, part B, we need to figure out the 51st term in the sequence. This is tricky. This is tricky. This is where we have to take into account that our sequence said the numbers were generated for x equals 0, x equals 1, x equals 2, and so on. So this is the tricky part. So when x equals 0, that generates the first term in our sequence. And the first term happened to be 3. When x equals 1, that generates the second term in our sequence, and that happened to be 7. So if we continue this pattern, I'm going to erase my x equals 2 because I'm running out of space. If we continue this pattern here, the question is, when we get to the 51st term, what would that number be? And I don't think that you want to make a list of 51 terms. That's going to take a very long time. So if you can recognize the difference here, that the first term, x equals 0, second term, x equals 1, what would x equal then for the 51st term? Well, it would be 50, because you notice the pattern that x equals one number less than the term we're looking for. So now we can go back to our equation and use our function notation and plug in 50 where the x is and simplify it. 4 times 50 is 200, plus 3 is 203. So the 50th term in our sequence will be 203. Our last benchmark for today, 8215, understand that a geometric sequence is a nonlinear function that can be expressed in the form f of x equals ab to the power of x. So geometric sequences where x equals 0, 1, 2, 3, and so on. All right, so f of x equals ab to the power of x. So that x is an
Hayden,
exponent.
boys, please come to the office. Hayden, boys, please come to the office.
All right. To use the equation for geometric sequences, the two variables that you need to replace are a and b. A will be replaced with the first term in the sequence. And then b is the common ratio. And the tricky part with the common ratio is that you have to express this as a multiplication relationship. So geometric sequences, you think of a sequence as geometric if the same thing is being multiplied or divided over and over. But when you write the equation for it, you have to be able to express it as multiplication. So whether you look at it as something being multiplied over and over or divided over and over, you have to express that as multiplication when you write your sequence. So for example, this is not the problem that you see here, but for example, if you had a sequence that started with 10, 5, 2.5, and so on, you would say it starts with 10, and you would look at this as a division pattern and say it's divided by 2. Remember that dividing by 2 is the same as multiplying by 1/2. So when writing an equation for this sequence, I would have to say f of x equals 10 times 1/2 to the power of x. So when it looks like it's a division pattern, make sure that you are able to express it as multiplication instead. Now, back to this problem, because this was a little easier problem. Here's our sequence. So the first term in our sequence here is 2, and then hopefully you can tell that if it goes from 2 to 6, that it's being multiplied by 3 each time. So filling in our equation here, I would do f of x equals the first term, which is 2, times the common ratio, 3 each time. So f of x equals 2 times 3 to the power of x. Now, to find the ninth term in the sequence, remember that when x equals 0, because according to our directions in the problem, when x equals 0, that's giving us that first term in our sequence. When x equals 1, it's giving us the second term in the sequence. So if you continue this pattern to get to the ninth term, it's 1 less each time, so we need x to be equal to 8. So f of 8 equals 2 times 3 to the 8th power. I'm going to use a calculator for this one. 2 times 3 to the power of 8 is 13,122. Now, realistically, that is a large number, but because the pattern was just multiplying by 3, and in the initial sequence, you see the first 5 numbers, so realistically, you could continue just multiplying by 3 and write out your sequence to get to the ninth term, and you would get the same result. When the number is smaller, like the ninth term is pretty small, writing a list isn't a big deal, but when they ask you for something like the 50th term on the last problem, that would be a ridiculous amount to write out, okay? So being able to use your equation to find that 50th term is important. This is our last benchmark for today.